Welcome to the forest. My name is Danny and today I'll walk with you through the research that I did for the past 5 months. I investigated how structural variables, such as competition, affect the drought resilience of Scots pine. This is a crucial topic as climate change is leading to more extreme droughts and is threatening forests on a worldwide scale. Let's dive in. Scots pine is one of the most widespread and economically valuable tree species in Europe, which covers around 20% of all commercial forests. Given the new climatic situations, it is crucial that forest management is going to adapt to a changing situation. But to change forest management in an effective way, it is crucial to understand some of the drivers of tree growth during droughts. In this study, we attempted to disentangle some of the factors that drive tree growth during droughts. The resilience is basically how well a tree can withstand and overcome a drought period. Let me sum up the main factors that we looked at. We looked at the DBH of a tree, which is the diameter at breast height. Number 2 is the species richness, so simply how many species a sample plot contained. Number 3 is the amount of competition a tree experiences. And number 4 is a competition per competing species that's putting pressure on the tree. Currently, we are standing on the Veluwe Zoom. This is where we sampled the trees. It is located between Dieren and Velp. The plots we sampled consisted mainly out of Scots pine, oak, beech and birch. To study the drought resilience of Scots pine, we collected samples from 60 different trees. I'll demonstrate to you how it works. It is important to angle the borer straight to the pith of the tree, perpendicular to the tree. This might take a while, depending on the species that you're coring. Now this extractor can go inside the hole on the back of the corer. Then you simply turn back 3 or 4 times. Now the core is ready for extraction. Now the core is extracted out of the tree and you can clearly see all the annual rings, with the lighter part being produced in spring and the darker part being produced in autumn. Here you can clearly see the pith of the tree, so we aimed correctly. After the cores have been taken out of the tree, they are glued onto holders like this. Then they are shaved for around 1/3 of their diameter and they are sanded. To assess the competition pressure the tree experienced, we had to measure a few other things. The first one being the DBH of the core tree, the DBH of the neighboring trees, the distance between them, and at last, which species those neighboring trees are. After extracting and preparing the tree cores, they could be analyzed and measured using a computer program. In this program, you simply put a dot on each new year, and this way you can measure the distances between all the annual rings. After this, the basal area increment was calculated, which is basically how much a tree actually grows each year. Finally, we use this data to compare tree growth before, during and after the very dry year of 2018. This allowed us to see which structural variables have an influence on the drought resilience of Scots pine. Let's look at the most important findings. We found that oak has a significant positive effect on the resilience of Scots pine when they are close to each other. Here in this graph, you see on the x-axis the Hedgie index, which is an index used to assess competition pressure. On the y-axis, it shows the relative resilience of Scots pine, which is basically how well the Scots pine was able to maintain or not maintain its growth during a drought period. There could be two explanations for this, with number one being a difference in rooting systems. Oaks tend to have a more deeper rooting system and doesn't compete directly with Scots pine, who has a more superficial rooting system. Second reason could be hydraulic lift. This is a phenomenon caused by oaks, where they close some of their pores in the leaves at night, and then they're able to move water from the deeper roots into the surface. And this water can then be used by Scots pine, for example. Another interesting finding is the negative relationship of DBH on the resilience of Scots pine. Here in this graph you see on the x-axis the DBH of the trees and on the y-axis the resilience. Each point you see is an individual tree. There's a significant downward trend going on, hence the red line. This is interesting since traditional thinning practices focus on selecting future trees, which are the bigger trees of the stand, and selectively take out the smaller trees. That way the bigger trees are favored, while they might have less resilience against drought. At last, we found that species richness does not show a significant relationship with resilience. Here you see a plot with three categories. Category low, which has only one species in the plot, and category high, which has 6 different species in the plot. Between the groups, there's no significant difference. This suggests that only focusing on biodiversity in a forest does not necessarily improve its resilience. Let's summarize the main findings. Number 1. The presence of oak trees in proximity of Scots pine enhanced the resilience of Scots pine. This highlights the importance of thoughtful species selection in mixed forests. Number 2. The bigger the diameter of the tree, the worse the resilience. This challenges traditional ideas where bigger trees are prioritized. Number 3. At last, having only more species in a forest doesn't necessarily improve the resilience of Scots pine. This suggests that we have to think beyond biodiversity and focus on how species interact and complement each other. Thank you all for joining me in the forest today. I hope this inspired you to think differently on how we should adapt our forest management to a changing climatic situation. Now, I give back the word to Dani in the lecture hall.